In this review module, we're going to look at density and how we actually measure it, and of course the math that goes along with it. So let's start with this question. If you were going to measure the density of water, which of these two devices would you need in order to measure the density? And I'll tell you there is more than one correct answer here. All right, so did you choose E and C? Well, those two are the correct answer because, of course, density is mass divided by volume. The only thing here that can measure mass is a scale, right, or a balance. Balance can definitely measure mass. Whoops. And all three of these can measure volume. I mean, a funnel is ridiculous, right? All three of these can measure volume, but of course a graduated cylinder is your best, most accurate volume measuring device because it usually has the most little graduations on it. These may have some graduations, some little marks, but they're not very, very precise. They go up by like 20 milliliters or 50 milliliters, but here that's your best device. All right, so that's question number one. Now, if we know that these two are the ones we're going to need, I want to know what units would you need for each one of these. What are the units for the balance and what are the units for the graduated cylinder? All right, did you say the units for the balance are grams and the units for the graduated cylinder were milliliters? That's right, so most density is measured in grams per milliliter. Now you may have seen, depends on which lessons your teacher taught you. If you were in my class, you learned that a milliliter is also the same as a centimeter cubed. They are the same thing, but really this is the units we most often use for density. Now you might wonder before we go on, would any mass and volume work here? And the answer is yes. If you could come up with others, your density could be measured in like kilograms for the mass instead of grams. You could use liters for the volume. You might even wonder, could I do like some other mass or weight? Like could I do pounds? That sounds like some sort of mass or weight divided by, I don't know, gallons. Yeah, gallons that's a liquidy measurement, right? So yeah, there are lots of units for density, not just grams per milliliter. All right, in our next question, we're going to actually calculate some density. So that means at some point you will need density equals mass divided by volume. So what I want you to do is I want you to read this question and I'm going to ask you a couple of questions about it that I want you to figure out. Okay, so if we want to calculate the density of this stuff, we need to know the mass. You see they have the mass of the graduated cylinder here. They have the mass of the graduated cylinder with the liquid. So how do we figure out the mass of the liquid? So imagine you've got 10 kilograms. Let me see if I can draw it right here. You've got a graduated cylinder that's empty that weighs 10 grams. You put some water in your graduated cylinder, whoop, like that. Now it weighs 15 grams. So how do we figure out the weight of the water? Well, we subtract those two, right? If we subtract out the empty graduated cylinder, so if I do 15 minus 10, I get 5 grams for the mass of the liquid. So we just subtracted out that graduated cylinder. All right, now we've got the mass, so we can go density equals mass, 5 grams, divided by, and then we got to have our volume. They said the volume was 7 milliliters. It was nice of them to just give it to us like that. And so if we want to calculate density, we do 5 divided by 7. And I get 0.714, but we've got to have units. Remember, it's grams per milliliter because no units canceled. And there we go. That's our density. Is that what you got? All right, so our next question, you can see, feels like we're about to do something mathematical, but let's not start there. All I want to know is, even though we don't have really enough math to calculate density, could you tell if the density of this rock was greater or less than 1, assuming that this water is liquidy? And I want you to explain, as in it is water, right? I want you to explain how you know if you're right about the density being greater or less than 1. All right, so the density is definitely greater than 1. If this is water, the density of water is 1 gram per mil, we know that this rock's density has to come out to be something a little bit higher than that. So if I told you that the mass of this rock when I put it on a scale, when I put it on a balance, was 52 grams. What I want to know is, what is the density? I want you to actually calculate that density and then type it in. So the answer I got was about 1.5 grams per milliliter, which for starters makes sense because it's more dense than water and the rock should sink. But if you didn't get that, let's walk through and see how that actually happened. And by the way, I said approximately. We'll see how close I was. Well, to get density, of course, I need to do mass, which we already know is 52 grams, divided by volume. But how do I figure out the volume? Well, the rock was put in water because we know as the liquid level goes up, the amount it goes up is the volume of the rock. And you see, I think they started right here at about 65 milliliters. Now, I want to be careful because you know we got to read graduated cylinders properly. You guys see how there are lines for 61, 62, 63, 64, 65? If there's actually a line for 65, that means we haven't guessed yet. So I think it really is on that line, so I'm going to say 65.0. But of course, if you wanted to say 65.1, that'd be okay. If you said 64.9, that would be okay. But you do need to have 3 digits here, right? Because we're learning how to read graduated cylinders properly. And up here, it's the same graduated cylinder, so we still need 3 digits. I think it's just a hint under the line 90, but I want to make my life pretty easy. So I'm going to say it's exactly on the 90 milliliter mark. But if it were just below it, it would be 89.9. 89.9. You can see that'd be 3 digits. So if I think it's on the line, I need 3 digits here as well. Now to figure out the volume of the rock, of course, we have 90 milliliters minus 65 milliliters. And that gives me, well, let's see, what is that? Ooh, I might have been off on my calculation. Is that 25? It is 25. I might have been off on my calculation down here, by the way. I'm feeling wrong about this at this moment. Anyway, so I think that's right. I think that's 25 milliliters. Let's see. 65, 70, 80, yeah, it's 25. So that is the volume of the rock. All right, so if we come down here and we say 25 milliliters, yep, I'm feeling like my answer is off a little bit. And then I do 52 divided by 25, I get 2.08. So it's even more dense than I originally said. 2.08 grams per milliliter. There we go. That's the actual answer. That one was wrong. And that's how you do that by volume displacement. All right, now the last one we're going to do before we get on to the second lesson, which has to do with density calculations. And I know you're thinking, we've been doing density calculations, but you'll see what I mean in the next lesson. But this is the last one I want to do. Now, I will tell you, if you were in my class last semester, or the last couple weeks, I did not do this kind of problem. So it's new and it's tricky. And if you already did it, then it'd be easy for you if you were in Mr. Sloan's class or Miss Kuhlen's class. But remember, density is mass divided by volume. They want you to calculate the density of this aluminum block. So I want you to take a stab at it. See if you can figure out what you think the density would be. All right, so of the two of them, which one's easier, mass or volume? Well, they gave us the mass. They said it weighed 10.25 grams. It's the volume that's hard. Now, if you're thinking, boy, just give me a graduated cylinder so I can throw this thing in the graduated cylinder and see the liquid level go up, that would absolutely work if you could do it. But they're not really giving you that choice here. And you can see they've measured the length, the width, and the height. If we want the volume of this cube, what would they tell you to do in math? Well, the volume of the cube is the length times the width times the height. And so to find that volume, you do 1.56 times 1.56 times 1.56, and you could get the volume of this cube, which I get to be 3.796. Well, let's see, it was centimeters times centimeters times centimeters. That must have been centimeters cubed, which we know is actually a milliliter, right? So now we know the volume. We can do 3.796 centimeters cubed, and then we can calculate the density. And I get 2.70 grams per centimeter cubed, right? Because none of those units up there canceled, and that's what I get for the answer. So it looks like C is going to be the correct answer. Hey, by the way, do you think this aluminum block would sink in water or float? Yep, it would definitely sink because its density is greater than 1, so it would definitely sink. All right, great job. So what I want you to do is we did a lot of mathematical work in here. Remember, upload that to Schoology so I can see the work that you did, and then we can go on to the next lesson.